There is a giant cloud in space hundreds of light years away from the Earth, with some of its areas concealing dozens of yet unborn stars. Others are ripped apart by tremendous flashes. The space here is permeated by lethal ionizing radiation and threads of red-hot hydrogen, and fiery vortices are capable of absorbing whole stellar systems. This is where stars are born, the stellar nursery which is closest to the Earth. What does it conceal from us? There are stellar nurseries richly scattered across the galaxy, with some of them comparatively modest in size. Others stretch for tens and even hundreds of light years. These are vast nebulae made up of interstellar gas and dust being inexorably compressed by gravity forces. Most of these tremendous clouds are barely visible against the abyss of space, but some of them can be seen from the Earth with the naked eye. One of these structures is the Orion Nebula, located 1,344 light-years away from the Earth. It is the middle object in the so-called Sword of Orion, a clearly visible line produced by three relatively bright light sources. Due to its large size and comparative closeness to the Earth, the nebula has been attractive for scientists ever since the early days of astronomy. It is hardly surprising, therefore, that this great structure is one of the best-studied space objects. It was the Hubble Orbital Space Telescope that beamed back first images of the Orion Nebula back in 1993, where the rich diversity of its colors can be appreciated. Most of the material was of a reddish or bluish-purple hue, while unusual bright green lines of some peripheral areas were revealed by spectral analysis. This phenomenon perplexed scientists for a long time, as the observed radiation did not demonstrate any chemical element known at the time. There was even a hypothesis that was put forward about there being a hypothetical element, nebulium, argued to be not present on our planet, but allegedly amply scattered across clouds in space. However, with the advancement of science, it turned out that the light was emitted by extremely rarefied and ionized oxygen. This discovery accounted not only for the bizarre illumination of many nebulae, including our Sun. There are currently not less than 3,000 stars discovered in the Orion Nebula to date, as well as giant clouds of interstellar gas and a great number of protostars. All this amazing diversity of space objects is concentrated in an area of around 23 light-years in diameter, all of them continuously and elaborately interacting with each other. The overall mass of the material concentrated here is around 10,000 solar masses. Looking at the Orion Nebula closer, we will notice several clearly defined areas. The most outstanding of them is Trapezium, also known as Theta 1 Orionis. It's an open star cluster about 300,000 years of age, made up of 8 main components. Some of them are binary stars, others have no companions. The brightest and most noticeable of the Trapezium stars are 4 stellar systems designated by letters of the Latin alphabet. Located close to each other, they lie within an area about 1.5 light-years in diameter. Each of these objects' mass is within 15 to 40 solar masses, which means that these stars are quite young and hot. Theta 1 Orionis C is the most massive, as well as the brightest star in both the Trapezium Cluster and actually the entire nebula. It is a white and blue main sequence star with a mass roughly 40 solar masses, whose radius is 8 times that of the Sun. The object's surface temperature is approximately 45,000 Kelvin, and its luminosity about 250,000 times higher than that of the Sun. The radiation of Theta 1 Orionis C illumines virtually all the nebula around it, but there is hardly any interstellar gas in its immediate vicinity. This is the case due to the fact it is typical for objects of this class to experience exceptionally powerful stellar wind that scatters rarefied material far off. Having traveled a few light years away from Trapezium, we will see another remarkable system, which is Theta 2 Orionis. It is made up of 3 gravitationally bound stars located close to the so-called Orion bar, an extensive feature of hot gas emitting bright light. It was impossible to study this area for a long time on account of dense clouds of dust, and thanks to the James Webb Telescope, more detailed images of this region have been beamed back to us. The first component of Theta 2 Orionis is just slightly less massive and not as luminous as the Trapezium's biggest star. As for its surface temperature, it measures about 35,000 Kelvin. The second component of the system is 15 times as massive as the Sun and 12,000 times as bright. The third component is as heavy as 5 solar masses, and its temperature almost reaches 14,000 Kelvin. However, it wasn't just bright stars that caught the researchers' attention. James Webb's infrared cameras allowed it to detect previously unseen objects, hidden deep within the clouds of gas and dust. Thanks to the telescope, about 180 so-called proplids have been discovered at the heart of the Orion Nebula. These are dense, dark protoplanetary disks surrounding stars that are still in the process of formation. One of these is Orion 294-606, a young protostar about 1 million years old, surrounded by a gas and dust disk about 300 astronomical units in diameter. Thanks to its being edge-on to Earth, we can observe its structure and size. It is expected to hit the main sequence phase in a few million years, and it will be accompanied by a system of several exoplanets and possibly their satellites. The night sky of these future celestial bodies must be a truly fantastic sight. Just imagine a multicolored luminous veil with the glow of a multitude of close and bright stars far more numerous than those seen from the Earth coming through. And now and then tremendous swirls of glowing gas cover half the sky, turning the night into translucent twilight. If we fly a little further and examine the wider region, we see that the bulk of the nebula is filled with scattered gas. The central part of the cloud is filled with highly ionized hydrogen, which actively absorbs high-energy stellar radiation. The temperature of this gas can reach 10,000 Kelvin, but it falls sharply towards the edge of the region. Temperature and pressure contrasts, as well as the collision of stellar wind streams, set material in space in motion, creating tremendous currents and vortices. According to calculations, some of them can reach speeds of up to 50 kilometers per second, and their size can be greater than the solar system. Also, in some areas of the nebula, thin strands stretching for several light years have been detected, consisting of relatively cool molecular hydrogen, without mixtures of methane, ethane and water. Further out, we will see that the central region of the Orion Nebula is enveloped in a vast cloud of cooler, denser gas. The cloud of bright stars and the luminescence of ionized hydrogen intricately intertwine here, creating a beautiful multicolored curtain of light. Hidden behind it are hundreds of space objects, invisible in the optical range. But the infrared cameras of today's telescopes allow us to see through the veil of interstellar matter. By combining data from different sources, astronomers have discovered about 700 protostars at different stages of evolution within this region. Their concentration is noticeably lower than in the central part of the nebula due to the lower degree of gravitational compression of the interstellar gas. The absolute majority of these objects are very young by space standards and are still in the process of formation. According to modern concepts of stellar evolution, new stars form during gradual gravitational compression of large clouds of interstellar gas. Typically, as a result of this process, giant nebulae split up into a number of closely grouped gravity centers, which soon turn into protostars. Such clusters are called stellar nurseries, or more scientifically, regions of star formation. At a certain point, the internal pressure of the compressed gas compensates for the gravitational forces, bringing the protostar to a state of temporary equilibrium. The remaining material swirls into a giant vortex disk, with some of it gradually absorbed by the future star, and the rest of it, by contrast, expelled far beyond the boundaries of the nascent system. The growing magnetic field of the young star also plays its part. As ionized particles accelerate through its field lines and then rapidly escape from the vicinity of the object, it has been calculated that such flows can reach speeds of up to several hundred kilometers per second. As they collide with the gas clouds surrounding them, they create large-scale vortices and hemispheres called Herbig-Haro objects. In the process, part of the kinetic energy dissipates into light and heat, giving these bizarre structures different colors. In addition, the ultra-fast motion affects the surrounding material, spreading shockwaves across it, which incidentally are also captured by telescopes. Since stellar nurseries contain many closely spaced protostars, each producing several gas emissions, it is not surprising that Herbig-Haro objects exhibit an amazing variety of shapes and colors. Clearly, being essentially the result of a major cosmic collision, they are highly unstable and variable. Herbig-Haro objects rapidly change color and shape, and typically disperse completely over several tens of thousands of years. During this time, they cover between 1 and 3 light-years on an escape trajectory from their parent stars. About 400 such objects have been discovered so far, with their total number within the Milky Way estimated to be about 150,000. Perhaps one of the varieties of this awe-inspiring natural phenomenon is the bullets, hundreds of astronomical units in diameter, also detected in the Orion Nebula. Moving at incredible speeds, they easily pierce thinner hydrogen clouds, creating far-flung shockwaves in them. According to spectral analysis, the frontal parts of these objects contain atoms of iron that glow in the infrared. The bullets are estimated to be about 1,000 years old, and their origin is still a mystery. They supposedly originated from some catastrophic event. Moving on, we will soon find that the Orion Nebula is part of a much larger cosmic structure called the Orion Cloud. It stretches for hundreds of light-years, accounting for virtually the entire constellation of Orion in the Earth's night sky. This is where the well-known Horsehead Nebula is located, remarkable for its bizarre shape. It is a dense dust cloud, about 3.5 light-years in diameter, clearly visible against a background of a contrasting scarlet glow. Also close to the Orion Nebula, there is an impressive cosmic structure called the Barnard's Loop. This emission nebula, about 300 light-years in size, came into being about 3 million years ago, after a series of consecutive explosions of mutually close supernovae. After the shock-compressed gas jets mixed together, they produced a gigantic curved nebula, and the glow of several young stars, gathered in an open cluster, made it reddish in hue. For all its beauty, the Orion Nebula is a fragile and unstable object by the universe's standards. Stellar winds and pressure of light from many young stars, as well as gas emissions and turbulent vortices, constantly disperse its material in the surrounding space. The nebula has already lost about 60% of its original material, and in about 100,000 years, it will be stripped of its remnants. In place of the shiny, multicolored cloud, there will remain an open star cluster similar to the Pleiades. For a time, the young stars forming it will move together, but eventually, each will find its separate way through the vast expanse of the boundless galaxy around. Even in spite of the long years of observation equipment modernization, James Webb has clearly demonstrated that we still haven't seen the universe in all its diversity. Thanks to the images from the telescope, we found that even allegedly well-studied areas of the starry sky may prove to harbor new amazing things to discover. The dark depths of space conceal countless mysteries. Who knows what we're to see there tomorrow?